Welcome, Nikhil.
Thank you. Thank you very much for having me. It has been awesome time here in Thessaloniki, and welcome everyone. I see people being seated, so I'll just give a minute more, or maybe I'll just start with the agenda of what I'm actually going to be talking about meanwhile. So it's cloud native CI/CD. So I start with understanding what are the limitations of cloud traditional CI/CD tools. I talk a little bit about what cloud native technologies are, and what are the benefits and specific challenges that we face with cloud native CI/CD. And we go on explaining different elements of what makes up these cloud native technologies. And then I start talking about some of the tools that we have in the cloud native world. Now, mind you, there are tons and tons of tools, and there's almost a new tool coming every month. So what I've here done is pick 3 common tools that are being used: Tecton, Jenkins, and Argo CD. And all 3 of them are kind of open source. But just as a disclaimer, there are tons of more tools, and these tools work with other tools. So, tooling world is very complex, and I could basically talk about the whole day about the tools, but I only have 40 minutes, so I have to limit it somehow. Okay, so we'll start with what cloud native technologies are. So I have a big bulky definition of cloud native technologies that I stole from this website, right? But the key elements of cloud native technologies are specifically, we talk about microservices, we talk about, and I'll explain each one of them in details. We talk about containers, right? We have all of this process of continuous integration, continuous delivery, and then we talk about DevOps, and in fact, you could go and expand SRE and platform engineering that are kind of built on top of this. But this is what we mean by cloud native technologies, right? Now, before the cloud native technologies, in the good old world, we had traditional tools, the most common one being something like Jenkins, right? Which typically you have source control, and every time there's a change, there's a pooling mechanism. The teams would check into 1 or more repositories. Tools like Jenkins, CI/CD, there are tons of them. There's a bunch of tools that are commonly used. They look at these source control systems, right? And they have these build agents that are always on. And the problem with these are that they were built in an era where microservices, containers, Kubernetes didn't quite existed, right? So they were not inherently cloud native, and they were hard to scale because you have build agents that are fixed number of build agents that are always on. Although I should point out that at a later point, this problem was somewhat kind of fixed in the sense that you can have dynamic build agents and you can have spot instances, what AWS calls them spot instances and so on. So there was some patchwork done here, but going into the depth of it, when you look at these traditional infrastructure that we have, there's too much of complexity involved, especially around the deployment side when you have many clusters, Kubernetes, configurations, help chart, and all sorts of things. Jenkins doesn't inherit, or Jenkins or these tools, and they don't really have a first-class support for them. There's too much of manual work that you have to do. It's very hard to maintain because inherently when you enter the world of microservices, and Venkat kind of mentioned about dependencies. You have too many dependencies. It's difficult to debug. So it's very hard to maintain with these kinds of traditional infrastructure. And then you have a whole bunch of configurations and permission settings, right? You have different environments. You have to manage the keys for them. It's kind of error-prone, and you can have a setup. Actually, this is something that we have practically experienced in my professional life, that there were keys in the debug and staging environment, and those keys were missing in the production environment. So we test the software, everything works great, and then we deploy it to production and things start breaking around because the keys weren't there. So it's really error prone to use them. Obviously, reliability is a very serious problem because they're not built on containers, right? So you're building on one environment and you're deploying in another environment. And ideally, your environments should be the same, but in really they are not. So you could have situations where your build and test and everything worked, and when it goes to the production, it breaks. On top of it, it's kind of expensive in a situation where these servers are always on. Although, like I said, there are temporary solutions that can reduce this problem of cost, but not eliminate it. In the cloud native world, where we have things like Kubernetes and Dockers and containers and all those things, we need a completely new approach. And this is the cloud native approach. So what is a cloud native approach then? Cloud native approach essentially is basically building and running your application that can leverage the cloud computing model and all these cloud native technologies. And I have some numbers here. And if you look at these numbers, right, you have like Netflix uses 600, Uber uses, actually at one point of time, Uber had 7,000 microservices until they realized they have too much of fragmentation and then they started consolidating. I don't know what the final figure is, but it still runs into 1,000. And WeChat, and you are deploying like, I don't know how many times a day or week. Such kind of, it's a very environment where things change very frequently. Like you have a change, you have many services, you deploy very quickly. And you need an approach which is fast, flexible, supports the cloud native, which is something that the traditional tools don't actually do. So what are the characteristics of these cloud native CI/CD tools that we are talking about? Or I should rather say, what are the desired characteristics that we would want to see that we feel are missing in our traditional infrastructure? To start with, one of the things we have to understand now is this containerization, right? Everything is built in containers. Tools like Jenkins don't really have a first-class support for containers. So that's one thing, that containers, everything should be built on containers. Services are immutable, right? Once you've deployed, you don't actually change that services. So it's immutable infrastructure. And then what we ideally want is we want our pipelines to be built in a decorative languages, right? So it's easy to understand, easy to share, easy to reuse. Then also, we would like to have some kind of integration with platforms, mostly Kubernetes, although ideally we should have other platforms also like Nomad, HashiCorp, and Mesosphere, etc., although they are less used, but at least with Kubernetes. And one of the things that we have in these cloud-native environments is that agents have to be agents and environment. Agents are basically dynamic, and we have many, many different kind of environment. For example, you could have multi-cloud, multi-clustered, everything, right? Again, the traditional tools don't really have all these capabilities built in. And then we are talking about very optimized resource utilization, right? We saw the numbers deploying 1,000 times a week. At that scale, where you're deploying 1,000 times a week, a little bit of saving on infrastructure can actually go a long way, right? Now, if you have something like, and the problem with these deployment patterns is that they are irregular. And certain times you might be deploying a lot, certain times you might not be deploying so many things. So if you have something like a fixed build agents, right, that doesn't really work. Even if you have scaling, you want something which is very fast, very fast can scale up and down, but at the same time, it has to be cost effective, right? You don't want to cost this to spiral out. So these are the desired characteristics that we would have, or things that we want in a cloud-native tools that we feel are missing in the traditional ones. But the question is that we are talking about all the problems. What are the benefits for it? Obviously, we have tons of benefits, otherwise we wouldn't be talking about them in the first place. So what are the benefits? Well, to start with, containers give us reproducible and reusable code. Now, one of the very common problems, and I think I briefly mentioned when I was talking about traditional infrastructure, is that you have this, you build something on my build agent and it works, and then I deploy it to production, things fail, because the environment where I am building, especially the dependencies, and in microservices, we do have a lot of dependencies. The dependencies are an environment of build and environment of run are different. So this is something that the containers would basically solve for us, because we are building containers which contains all the dependencies. So it's like an all-in-one full package that I can just take this container and put it anywhere in my production environment, whatever cloud I want, in my test staging environment, and things would behave pretty much the same. So that's a huge advantage that I have with these cloud-native CI/CD technologies that use containers. Then we have dynamic orchestration. We are dealing with things at scale, right? We saw that we are talking about hundreds and sometimes thousands of services that are running. At that scale, things fail. And even if your infrastructure is 99.99% reliable, you still will have occasional outages at that scale. And so what you basically want is you want some kind of orchestration mechanism that looks at your environment and kind of make sure that everything's working, and if something is failing or something is not desired, it should be able to fix it. dynamically. You shouldn't have to stop everything and redo everything, because then it basically, if you do something like that, right, then your services would go down and it can lead to a lot of loss of revenue. Imagine if Amazon, every time they want to deploy something new, have to shut down the website. Every second of shutdown will cost them thousands of dollars, possibly millions, I don't know, at the scale at which they operate. So dynamic orchestration would help you solve that problem. Then you have something like more efficient or serverless resource utilization, right? Because if we saw the problem that when we have like always on services, the cost can spiral out of control. So what we ideally want is that when we have the serverless resource utilization, as and when we need the resource, it should come up, we will get billed for that, and once we don't know, the system will scale down, so I'm not going to be billed for those resources that I'm using. And the benefit I have here is I have reduced cost, okay? And then finally, we want conformant APIs that behave consistently. And what the advantage we get is portability. Now we are talking about an environment which can spread across multiple clouds, multi-clusters. So portability is something needed, right? Gone are the days where you have like one kind of environment, one kind of operating system, everything is like very deterministic. Now, things are not like that. So these are some of the benefits that we get using cloud-native CI/CD. But for every benefit that we have challenges. So let's look at some of the challenges that we have. Now we are dealing with container images and not binaries, which is something that our traditional infrastructure don't quite support. Then we have many clusters, right? It's not like we have a single cluster, not just across the cloud, even within the same cloud. Then we have microservices, and microservices contains dependencies. We know hundreds or possibly thousands of microservices with all their dependencies. It's a very complex environment to manage. And then we have these ephemeral environments, right? Especially in the serverless world, these environments are short-lived environments. They come up as we need, and then they will scroll down. So we can't really make an assumption that these environments really exist. These environments are pretty short-lived environments. They come and go. And whatever method we have for deployment for our tooling has to basically take care of all of these challenges that we have. So I'll start exploring some of the elements of cloud-native technologies. I'll start with containers. Containers are fairly basic, so I'm not going to spend a lot of time on it. I'm assuming most of the people would know, but just for complicity's sake, we have a binary and all its dependencies that are packed together, right? And containers basically contain the operating system in it, and it kind of runs in an isolated process. And this is like a stack. You have like operating system and your engine, and then you have multiple containers because you have multi-tenancy, and that is giving you the advantage that your resource utilization is pretty high. And you have ecosystems of lot of languages, lot of libraries, and lot of binaries. So that, developers as a group tends to be very opinionated about the tools, the frameworks, the languages they use. They don't like to be told, this is the best language or framework. No, they have their own way of doing things. So containers have this advantage that they have a big ecosystem that you can pick and choose which one works best for you. And then we talk about Kubernetes, right? By far the most common orchestration tool platform. Basically, it's a platform for managing containers, right? Containers at scale. For those who don't know, Kubernetes actually comes from a system called Borg, which Google initially developed, which was in C++. And Kubernetes is kind of an open source version of Borg, but it's rewritten from ground up in Golang. So Borg originally was a C++ system. And it does a lot of things for you. So it's basically, it's an operating system for your data center. Think of it. So it does all things like resource allocation and scheduling for you. Like if it manages containers, so provision and deployment of containers or tear down. It would take care of load balancing and traffic routing. It takes care of scaling activities. We have talked about approaches where you have resource optimization, so auto scale up, auto scale down. Kubernetes can handle all that. We know that when we operate services at scale, failures happen. So one of the things we need to do is some kind of monitoring of containers, so health monitoring. It's basically, essentially, I describe my ideal state, and the system is looking at the actual state, and every time there's a discrepancy, it tries to match the actual state with the desired state. And above all, it is actually abstracting out a lot of resources for me. So computer, networking, storage, everything is kind of abstracted out. So what are the benefits of this ecosystem? For one, it follows infrastructure as a code paradigm. Horrible amount of YAML. I don't like YAML, but some people do, for whatever reason. When you have infrastructure as a code, you obviously can, we'll talk about GitHubs where we'll explore GitOps, which will basically explore more about it, but you have like version control for your infrastructure. You have optimum resource usage, right? Because you have many, many pods, and you can just, you have zero downtime, you have rolling updates. And of course, you have self-healing in case of failures, which is what I mentioned about, right? Desired state and the actual state, and try to basically manage. And you can scale up and scale down very easily. So there are a lot of benefits for Kubernetes. And then Kubernetes is it's somewhat complicated, but you have Helm charts, which basically is a package manager for Kubernetes. So essentially what it is doing is helping you simplify deploying and management on these clusters. It allows users to install and upgrade very complex applications. And then obviously it has some collection of pre-composed resources, templates, etc., that you can actually use. So it's basically you can extend Kubernetes your own way. Now, moving back to cloud native CI/CD, we want to talk a little bit about containerized pipelines. Now, why do we need containerized pipelines? We saw the benefits of containers, that with containers, you basically have all the dependencies packed across with the environment. So you have portability across environment, right? So that is one big reason why our pipeline should be containerized. We have isolation and reproducibility because we can replicate these containers any number of times. It goes to the container registry. I can deploy it anywhere. We have isolation because all my dependencies are packed. So I'm not too much dependent on an environment. I have scalability. I can scale as many times I want. I have faster build and deployment times. And above all, because my container registry, I basically put all these containers and they kind of versioned. I have versioning, and then I can roll back. Now, we have talked a lot about all these configurations and YAML and etc. But the problem is, where do we maintain this stuff? This has to be somewhat maintained in a kind of a centralized fashion. And this is where GitHub basically comes in. So what is GitOps? GitOps is essentially, think of Git as basically having a single source of truth. Now, up until now, we are using Git as source control management. But now when we talk about infrastructure as a code, we can take our infrastructure also and put it in Git. And then we could say, well, this is our system, basically, the whole infrastructure in Git that we maintain, and this is the truth. Like, this is the single source of truth. We can have replicas, but this is what we believe is the actual truth. And then, so GitOps is essentially a set of practices that basically leverage Git as a source code for defining, managing state of infrastructure and application, because once your infrastructure is basically put in a code, then there isn't a lot of difference between what is an application and what is an infrastructure, because at the end of the day, it's just code, right? And then what you can have is you can have things like declarative configuration, right? So I can have a configuration where I basically declare what I can. And there are a lot of good tools that actually do that. I know there's Pulumi and so on, which if you have to deal with a lot of complicated infrastructure and you don't want to deal with YAML and so on, they actually use programming languages like Python, where you can define your own infrastructure. So you have declarative configuration. Once you have it on Git, you have version control. And this is a big deal, because if things go wrong in your infrastructure, you can actually roll back in time and go back to a point where you know things were working, right? So you have an auditing built in. If you have it on Git, then you have continuous deployment, right? You can just, every time there's a change, there's a pipeline, I have a new version of infrastructure, I notice a change Git, I deploy my new infrastructure, so there's a continuous deployment built in. Above all, you have pull-based operations. So a pull request, you can actually see the changes that are happening to your infrastructure. And then you have observability and rollbacks, right? You can observe how the infrastructure is behaving, and if something is going bad, like I said, because you have the entire version history, you can actually roll back in time. So that's a big advantage. We're talking about advantage, so let's actually look at some of the specific advantages that GitOps would provide. So GitOps basically, tools there like Argo CD, they're all associated with a lot of these tools. Argo CD, we'll talk about all these tools. They actually kind of incorporate GitOps, but these principles are pretty general. And one of the things about Git is consistency, right? There is one source of truth, because when you have multiple versions that can deviate, you don't know what is true and what is not true, right? What was the original intention? With GitOps, you have like, okay, Git, whatever is in the Git is basically the single source of truth. And once it's on Git, you can actually collaborate with your teammates, etc., etc. Then you have version and auditing, which is built in on Git. So far we have talked about general elements of cloud-native technologies and some of the concepts around it. Now I go back and I start talking about some of the tools that are there in the cloud-native landscape. And here I'll mention that I've only picked up 3 tools, right? There are tons and tons of tools. So we'll start with Tekton project. Tekton is basically kind of a foundational project, and they have a nice, wonderful website. And it's a powerful open source. There's a definition framework that provides and standard components for cloud native CI/CD tool. Now here I actually want to clarify, you can treat Tekton as like a CI/CD system, but in a sense, Tekton is a loosely coupled set of components where you can use it to build your own CI/CD tool. Now, this is a common problem that organizations face, that when they scale up, they need kind of a custom CI/CD, right? Your off-the-shelf components won't work. But building your own CI/CD can be complex. So this is where Tekton can provide you with a great starting point where it has all of these various components available, and you can use that and put them together and modify them as you need to build your own custom CI/CD solution. In fact, Tekton is the foundation for a lot of projects. Jenkins uses Tekton as a foundation, which is kind of an open source but more opinionated, fully packaged CI/CD tool. Apple has a proprietary CI/CD system called Rio, which basically uses Tekton underneath it, which is obviously only Apple and solves for specific problems that Apple faces, not open source. It's not even available to outsiders. Tekton came with a vision that it should be composable. We saw in CI/CD tools, right? We want things to be composable. We want to combine and recombine our pipelines. So composability is there. It's declarative. I want to be able to just specify what I want. I don't want a prescription. I want a description of what I want. Reproducibility. I don't want any kind of surprises where things work in one environment and things don't work in another environment. I need, obviously, cloud-native support. So the vision of Tekton essentially was that Tekton was basically kind of all-in-one. It combines all of these, and it has the building blocks. And let's actually talk about some of the building blocks of Tekton, right? So building blocks of Tekton, you have a simple step, and a task contains set of, I'll just pause and I don't know if I have time to show a demo, maybe not. But a task basically consists of set of steps, and then you build a pipeline, and a pipeline is a directed acyclic graph of tasks. And then you combine these pipelines with the pipeline resource, or a separate task with a pipeline resource, and you get like a fully cloud-native CI/CD pipeline. The resources, when we say resources, we are talking about source code, repository, etc. The resources are not included in pipeline itself. because your pipeline has to be composable. So I don't want it to be tied down to a specific repository or specific project. I want this pipeline to be used across multiple repository. I want these pipelines to become higher order pipelines to use these lower order pipelines, right? They should be able to combine. So that's why deliberately the design was such that the pipeline resources were actually kept separate from the pipeline. And the way Tecton started, it had its own very interesting history, that there was a project called Knative, which basically was serverless containers for Kubernetes. Okay, that started, it started as a consortium. It started at Google, and then I was at that time at Google when I was actually working on the serving component. So it was basically Google, Red Hat, Pivotal, and a couple of them. And it was essentially an open source project. It still is an open source project. You can actually go to knative.dev. And it had three components: build, right, how you build your code. It has serving, how you route your traffic. And it has events, because serverless is about events, right? And deliberate decision was made that these would be loosely coupled components, so people can use mix and match whichever way they want. Like they may want to use the build only and not care about serving, or have their own serving. And then there were commercial products that were built. So if you go to Google Cloud Run, it's actually built on Knative project. Now, what happened was that at the time, there weren't good cloud native solution. So what people started using was they started using build in its rudimentary form and just started using it as like a cloud native CI/CD tool that they have, right? And when build became very popular, it was basically decided that rather than tying it down to Knative, what we're going to do is we're going to take it out in its own project. And I think it was version 0.8. Now Knative is 1.1. I don't remember which version they have it now. After 0.8 version, build was taken out and spin out into a separate project called Tecton. And this is how Tecton pipeline basically looks like. It's a simple YAML. You have all of these scaffold and Maven tools. Here, what I would do is I would not have time to basically show a demo. But what I can do, let me just do, is point you to some of the resources that, okay, hold on. Sorry, knative.dev. So let's actually go to tecton.dev. So this is the Tecton project, right? And it's a cloud native. We already talked about it. And it's actually vendor neutral. So CD Foundation basically manages this. So you don't really, because a lot of times what you don't want is you don't want vendor lock-in. So it's a completely open source CDF Foundation. It's friendly to people who want to collaborate or basically contribute. And originally, it came from tecton.dev. So this was the original Knative project from where it was spin-off. And I do have a demo, but you'll find a lot of demos basically in the web also. So, which basically, I won't have time to actually show it right here because I have other things to talk about, but it's just a handout demo that if you want to play with Tecton, you could actually do that. That's basically the link. Anyway, so from Tecton, let's move out. How much time there? Okay, I have some time. No worries. Okay. From Tecton, we basically come to Jenkins. Jenkins is different from Jenkins, okay? So they are two completely different things, and they just share some philosophy together, but other than philosophical similarities, they are actually a totally different code base. So Jenkins was created by this guy, James, who's basically creator of Groovy, Apache Camel, etc. And what Jenkins essentially is, we saw the problems with Jenkins that it doesn't really support cloud native technologies. So Jenkins in its essence was a redesign where we start with like ground up to be cloud native, Kubernetes native. So like I said, it shares the philosophy of Jenkins, and the philosophy of Jenkins is that we want extensive automation server, right? And then you can extend it any way you want via plugins. And you can make it as a CI server, CD server, just about tool to automate anything. People are running Jenkins for like, running workflows for machine running and all those things. So Jenkins X essentially shares the same philosophy as Jenkins, but in terms of its actual implementation, it is very widely developed. The one thing that I want to point out is that Jenkins X is a very opinionated server, right? It believes in something which is like, this is the right way to do it. You have the freedom to change it, you have the freedom to extend it, but it has its own strong opinions on things. And it supports a lot of basically clouds out of the box. So it has plugins for Google Container Engines, Red Hat, Amazon. Because it's kind of open source, and Jenkins, like I said, it shares the philosophy of Jenkins. So it's extensively automated. So you have all of these out of the box support for all of these various services, and of course, Minikube and Minishift. So what is the difference? What are the benefits and drawbacks of using Jenkins X? First of all, the big benefit, this is a cloud-native solution, supports out-of-the-box support for Kubernetes, right, which is something Jenkins really doesn't have. And then automation of CD pipeline, right? So we have this philosophy of shift left, which ties down to the philosophy of being agile, right? You wanna detect something if something is wrong as early as possible. So shift left. So Jenkins X supports that. And then you have ready-to-go pipelines for a lot of things, common tasks like building, etc. Because if you're using standard build tools, you will have basically ready-to-go pipelines for that. But obviously, with some benefits, there will come some drawbacks. So what are the drawbacks for Jenkins X? To start with, if you're using existing Jenkins X, right, it takes effort to migrate pipelines to a new platform because, like I said, they share spiritually the same thing, but their actual implementation is wildly different. And traditional Jenkins plugins don't actually work here. And Jenkins X, it has a command line tool called JX, but unfortunately, and I don't know why, the UI support is not that great. I mean, you have UI for Tecton also, you have UI for Jenkins, but there's no official, well-supported, production-ready UI. Different people have their own UI implementations that you can download, but like I said, there's no official. If you go to Jenkins X, and let's actually go to Jenkins X. You actually have a command line tool called JX, which is like the officially supported tool. Now, one common question that I often get is, what is the difference between Jenkins X and Tecton? And I'll talk about differences more towards the end, but the short thing is Tectons is basically a loosely coupled set of components, not supposed to be a finished product, right? It is just something that you build upon. Jenkins, on the other hand, is a finished product, opinionated to do things in a certain way. They use each other. A lot of things that Jenkins X actually does, it uses Tecton components underneath. Okay, so now moving on from Jenkins X, I have about a couple of minutes left. Okay, so we have talked about this. Let's talk about Argo CD. So what is Argo CD? Argo CD specifically talks about declarative continuous deployment tool, which the key point of Argo CD is it follows the GitOps methodology, right? It supports Kubernetes and it follows the GitHub methodology. Now here I want to point out that Argo CD, like the name suggests, is more geared towards CD, not so much about CI. So in practical uses, what people do is they will have Argo CD, but for CI part, they would probably use some other tools. You can actually, because they're all open source and somewhat flexible, you can mix and match in the sense you can use Jenkins X for your build and then Argo CD for deployment, or you can even have a traditional Jenkins. It's just a little bit more tedious. But just for building containers, Jenkins is probably not that bad. It's the deployment part that gets complicated with Jenkins, so you can couple Jenkins with Argo CD. So, yeah. And it follows the process of GitOps. So you basically have a desired application state that you store in GitOps, and it is continuously monitoring and making sure that your desired ops, basically your desired state matches what the actual state matches what your declared state is. And it's designed to automate deployment and management of application Kubernetes, right? Like I said, it's basically geared more towards the deployment part of it. So what are the features of Argo CD? Well, there's a web UI, there's a CLI, it supports both. It supports multi-clusters and multi-tenancy. It's even multi-cloud, which is great. Following the principle of GitHubs, you have roll back and roll forward. And again, following the principles of GitOps, you have basically synchronization and health status. And like most of these open source tools, they are inherently designed to be very extensively customizable and extendable, right? So let's actually look at so let's actually go back, and I am going to look at Argo CD here. Sorry, Argo CD. Yeah. So this is the website for Argo CD. You see the nice UI. If I go into details, I can spend hours on this, but I don't have that much time, so I can't go into the details, but you can explore. And it's open source, so you have the GitHub repository here. Okay. So one of the things I actually wanted to do was I want to compare these tools, right? I want to understand what are the differences in what state. So let's do a little bit of comparison, okay? So what is Tekton? We talked about it. Essentially, Tekton is providing you building blocks. It's not so much of a finished product, more of the product where you want to build your own custom CI/CD tool, a great starting point for that, and lets you build. I gave an example of Apple. Apple uses Tekton to build their custom CI/CD tool called Rio, right? Jenkins is more of a finished product, which talks more about, which is both end-to-end CI/CD platform, but it has its own set of strong opinions, right? It's not flexible. You can mix and match any way you want. Of course, you can extend it with plugins, right? But it has its own opinion, and it has built-in environments for different stages of development lifestyle. Spiritually, it shares the same thing as Jenkins, like open extensible automation server for pretty much anything, but is just spiritually similar to Jenkins. Not actual implementation is totally different. And then lastly, we talked about Argo CD, right? More focused on deployment, following GitHub's principle. You probably would need something for build in addition to Argo CD. But a lot of organizations, I think Splunk uses Argo CD in a big way. But yeah, follows the GitHub's principle, ensures that desired state defined and actual state matches. With that, I have about 2.5 minutes remaining, so I'm up for questions.
Thank you very much. We have a few minutes for questions. Anybody want to put a question to our speaker? There we go.
Hi, great presentation. What's your opinion on the latest shift to usage of the GitHub Actions, GitLab Actions, where they are trying to create CI/CD with the open source steps, meaning.
Okay.
Yeah.
So personally, I love GitHub Actions. I should tell you that. Now, GitHub Actions basically provides you the problem with GitHub Actions is when you go into deployments, they're good for simple workflows, right? But the moment you go into complex deployments, into multi-cluster, red, blue, green, canary deployment, etc., it would get very tedious to use GitHub Actions. So the usage that I think about GitHub Actions is great for building, okay? Great for workflows. Like I have a pull request, I create a pull request, I want to make sure all my unit tests are passed, Another very common usage for GitHub workflows is that, you're using libraries. Periodically, the workflows would run and check that you're not using any duplicate code. For all those things, I think GitHub workflows are fantastic. When it talks about complex deployment scenarios, GitHub workflows don't really work well. That said, you have to also understand that a lot of these toolings, including GitHub Actions, they're not either or. They actually use in combination. For example, your GitHub Actions can be your entry point that would trigger a deployment on Tekton or trigger a deployment on Argo CD. So you could, a lot of times, including my organization, we have our own cloud native CI/CD tool, right? It's called Yomato. But generally, GitHub Actions will trigger a job there, right? So GitHub Actions, I see GitHub Actions as a great simplified workflow for developers for doing not just CI/CD, but for a lot of code maintenance, right, deprecation detection, and then they can be acting as a gateway to more complex scenarios. That answers your question? Okay, next question.
Yes.
Hello, my name is Alexey. I have a question. Which of these tools you prefer to use in development?
Okay, so I personally, answer is none. And the reason is that we need, a lot of times in organizations that I've worked, we need custom tools, right? So it's unlikely that we will use out of the box. So we would use Tekton as a base to build our own tool, right? Which is what I mentioned, like Tekton provides me a building block. So if you were to pick which of the three I'm closest to, I'd probably say Tekton, right? But I'm not going to be using Tekton as it is. But I'll generalize your question and say, which one should I use? And the answer is, if you don't want to spend time building your own CI/CD, you just want out-of-the-box solution, Jenkins X, great. If you want to build your own CI/CD, Tekton. If you think that your build tools like GitHub Actions can do a fantastic job building, they just are not good at deployment, I can use GitHub Actions with Argo CD. Those would be your choices. And of course, mind you, there are a lot of other tools that I haven't covered, so.
Great, thanks.
Yeah.
We'll take one more.
Hi, thank you. What's the real matter to use Tekton instead of just developing your CI/CD pipelines in your GitLab?
Sorry,
for example?
could you repeat your question?
Yeah, please. So what's the matter to use the Tekton and not just to use CI/CD in your GitLab? As I understood, the Tekton feature is to stick to the custom resource definition in Kubernetes, and
yeah.
so you put your pipelines there, but I can use, for example, simple way with GitLab.
So I'm not super familiar with GitLab, so I can't compare it with GitLab. But I would believe GitLab is basically, again, it's a finished product, right? So again, it goes back to the very point that if you want something that just works out of the box, you might as well use GitLab or Jenkins X, right? That will serve your job better. Tekton isn't really designed for that scenario. So in that case, forget about Tekton. I do not know specific implementation of GitLab, but a lot of these tools, they use Tekton underneath. So you might be using Tekton, you just don't know about it because it's abstracted out for you.
Okay, thank you.
Yeah.
Hello, thanks for your presentation. And my question is, in the beginning you told a little bit about that sometimes your configuration is dependent on environment, but with containers you sometimes still want that because you want, well, maybe specific keys, maybe specific certificates, and maybe you can share your favorite solution for this. Thanks.
Yeah, so here there is a CI part and there is a CD part, right? Containers are mostly used for CI part. Your build should not be dependent on the keys, right? Keys, like the specific example, your keys are more on the deployment part of it. So yes, you want to keep them separate because when you're building, you're not building for a specific environment, whereas keys are tied to a specific environment. So what you ideally want is you want build to be environment agnostic, right? And whatever metadata you have to give to that build, you give it separately on your deployment start of it. So that's where the keys would come in. Yeah, so that has to be provided separately through your mechanism, whatever resource you're providing, right? It would not be integrated in your build. Typically, I think there are tools like, and HashiCorp has some console and all those service discovery tools that can be used for secret management also, if I'm correct. That's what we used last time, I remember. So your keys would actually go separate, not part of your container. You could do that, but it's generally not a good idea.
Nikhil, thank you very, very much for that talk.
Absolutely.
Appreciate
Thank
it
you
very
so
much.
much,
Thank
sir.
you.